Hello everyone, my name is E-Hassin. I am a student at North South University. Today I'll be talking about my research work entitled Smart Fire Detection and Security System, which I have been doing for my academic purposes. The contents of the presentation includes motivation, system design, result analysis, cost analysis, and finally the key findings, which will conclude the presentation. In the next couple of minutes, I'll give you a brief introduction to my research topic. So let's get started. Sudden fire incidents are a common phenomenon in Bangladesh, especially in Dhaka city. More precisely, we can declare this as a global issue. Fire events in factories, garments, industries, buildings, warehouses are consistent new, which takes many lives and property. The number of fire incidents is growing faster with the increase of industrial organizations. Every year, a massive amount of people die because of sudden fire incidents worldwide. Today, I would like to introduce you to an effective fire detection system through this presentation. According to the fire safety experts, occupants could get only a couple of minutes to save themselves when there was a fire outbreak at their premises. To prevent the uncertain death and loss of property from the fire hazard, early fire detection and monitor have significance. Apart from that, security becomes an essential fact in our modern life. To enhance the safety of humans, a security alert system is crucial, which will detect any sort of motion in the designated area to detect the presence of a potential intruder. Our goal is to design a portable, battery-powered, efficient unit that can detect fire at an early stage at a minimal cost. As a result, everybody can afford it pretty easily. In this section, I'm gonna talk about the methodology, main features, system design, and implementation process. There are four types of fire detection systems available in the market, which are infrared-based smoke detector, ionizer-based gas detector, radiation principle-based smoke detector, and a combined type which contains both smoke and gas detector together. The response from these devices are not optimized for every situation because this detects fire based on a predefined fixed threshold level which was set by the manufacturer during release. Here our prototype is pretty unique because it can set its threshold level on its own. It can do self-learning by observing the surrounding. As a result, it detects fire at a preliminary stage within a short time. Also sense sudden temperature change, the presence of flammable gas in the air, and flame as well. It can operate independently. It's also IoT enabled, so users will get notified through the internet. Another unique feature, it detects motion signatures during a fire event, so we can confirm the presence of trapped people at the affected area remotely. There are four sensors which are temperature, gas, flame, and motion equipped with this system. It collects raw data from these sensors. After that, a custom built algorithm processes those data and generates a decision. It saves all of its learned data and other valuable information to its permanent storage during shutdown or power loss state so that it can retrieve previous data from its memory when needed. For example, at first it observes the environment, then it calculates the minimum and maximum temperature. The threshold value is calculated by the combination of previous data and freshly processed new data in a specific interval. When the present temperature crosses the threshold value or threshold temperature, then it will generate an alert. When the present temperature is less than minimum temperature, then it will recalculate the threshold value. If the decision is positive, then it will increase the possibility by 10% each time. When it gets negative, then the possibility decreased by 1%. If the possibility becomes 50% or above, then it will check for similarity in its entire dataset. If match found, then it will increase the possibility by 20%. If it goes more than 90%, then it's strictly positive. In that situation, the alert system will trigger the alarm. The alarm remains high for 1 minute if triggered once. Meanwhile, it will start a timer for 60 seconds. If the situation is not in the normal state, then the counter resets again and again to its maximum value, which means 60 seconds. If the situation becomes normal, then the counter becomes zero gradually. The same pattern is applicable for both flame and gas sensors as well. The system works in two modes, normal mode and away mode. When the system is in normal mode, then normally the motion sensor remains turned off. It will turn on automatically if there is any abnormality detected by the other sensors. In that situation, if there is any motion found in the targeted area, then the motion response becomes positive. On the other hand, if the system is in away mode, then the motion sensor will continuously search for motion signature. If found any activities, then it will trigger an alarm. In this way, this unit can be used as a motion-based security system. This unit periodically sends updated data through the Wi-Fi to a designated database server so that the web portal can generate appropriate info for the user. The system can run independently and also as a part of a large network as well. This figure shows the internal architecture of the system. When this unit works as a part of a large network, then there is a controller unit present in the entire network. The controller unit collects all data from all remote units nearby and also sends a copy to the database. We can connect a maximum number of 100 remote units under a single controller. This is our initial release prototype. The inside view is on the left and the outside view is on the other side. Now let's discuss different case studies, device performance, and similar topics. If we keep an eye on the serial monitor, then we will get this diagnosis view. The system collects data every second. Every 10 seconds, it calculates the average to obtain the value of 1 minute, 10 minutes, 1 hour, 6 hours, 1 day, and finally 1 week of data. These are the graphs generated by the web portal. We ran some tests into a controlled environment and compared the result with some commercially available similar devices. See, the result looks promising. In the graph, the red bar denotes the result from our system. Now let's begin the cost comparison. This table shows the price of commercially available devices and also shows the total design cost of our system, which seems pretty less compared with others. In this section, I will talk about key findings. Finally, we have got a system which features similar but fast, reliable, and efficient results at low cost. The self-learning technique makes it more reliable and optimized for any environment. It can correct errors automatically with the help of the self-learning algorithm. It can be used as a motion-based security system as well. We are trying to make it compatible with off-the-shelf firefighting system. We will add the GSM module in future, which acts as a failover when Wi-Fi or the internet connectivity is not available. And of course, we will make it more optimized and energy efficient if possible. Here is the list of references where we have got tons of knowledge during the making of this prototype. That's all, folks. If you have any questions, I'll be happy to answer those. Thank you all.